Good evening, sir. Myself is Baba Ambar and my teammates are Sanjana, Anusha and Mohita, and our topic is Arduino drone.
Hello, sir. Myself Mohita, and my topic is about the introduction part. And here is this project focuses on designing and developing a quadcopter drone, which it has been four quadcopters drone using the Arduino microcontroller platform. And this drone indicates various sensors, brushless motors, and electronic speed controllers to achieve stable flight control. And the aim of the project is to understand the fundamentals of the drone and flight stabilization and embedded system programming by implementing Arduino-based controller logic. This drone offers a cost-effective and customized approach to UAV technology. The next is about the problem statement. Coming to this, commercial drones are often expensive and complex, making them difficult for beginners to understand, to customize, and to repair. This is the need for a low cost and easily programmable drone that allows learners to explore the fundamentals of unmanned aerial vehicle (UAV), which means technology. This project addresses this need by developing a quad rotor drone using Arduino, enable hands-on understanding of flight control, sensor integrations, and embedded system programming. And the next coming to the objectives to design and develop an effective quadcopter using the Arduino platform. And the next one is to understand the principles of drone aerodynamics and stabilization, and to integrate and program sensors for stable flight control, which such as gyroscope and accelerometer. And the next one is to interface the brushless motors and electronic speed controllers with Arduino, and to develop control algorithms for takeoff, to test and evaluate the flight performance of the drone under different conditions.
Next, coming to the hardware and software requirements. And in software requirements in Arduino IDE, it is helpful to write the code and test the program for controlling the drone. And next is IMU sensor library, which is also known as the MPU 6050, which is used to read motions data like angle, tilt, and rotation of the drone. Next, PID control algorithm code, which helps to keep the drone stable by correcting its balance during flight. Serial monitor and serial plotter, which is used to monitor sensor values and debug the system. Next, coming to the hardware requirement, the main use is ESP32, which is the brain of the drone. It processes sensor data and controls the motor speed. Next, IMU sensor, it measures the acceleration and rotation to maintain the drone stability. The four brushless DC motors, which is used to rotate the propellers and lift the drone into the steer. The next, electronic speed controllers, which controls the speed of each motor based on signals of the controller. Quadcopter frame, it provides structure and holds all components safely. Propellers, which are four, which two runs in clockwise and two runs in counterclockwise. And lithium potassium battery, the power distribution board, which is distributes the power evenly from the battery to electronic speed controllers and other parts. RC transmitter and receiver, which is an Bluetooth module used to control the drone wirelessly. Then connecting wire screws and mounts, which is helpful to connect the secure all components properly. Next, coming to the methodology. In this literature review and planning, study of drones is used for aerodynamics, flight control systems, and Arduino interfacing, which is identify the project requirements such as it has size, weight, and stability, which is cost effective, and component selection and procurement. It required components like frame, brushless motors, ESCs, propellers, and IMU sensors, battery, and ESP32. Then hardware assembly, the motors which are mounted on the quadcopter frame and connected to ESCs. Then to install the Arduino and IMU module, the power connections are made using a power distribution mode. Next will be continued by Sanjana.
My topic is about the flow chart. So first start, the drone system is powered on initialize all components like sensors, controllers, and motors get ready for operation. Check throttle position. The system checks whether the throttle is lower or safe. If not, checking will not proceed. If yes, it continues to the next step. The drone reads values like orientation, angle, and gyro, accelerometer data. Read receiver, the system reads the commands given by the remote controller. Compare values, it checks whether the sensors and receives commands or match. So decision, if they are equal, drone is stable, continue flying smoothly. If they are not, drone is unstable. Apply PID algorithm. If unstable, the PID controller calculates the corrections needed. Adjust the rotor speeds based on the PID output. The motor speeds are modified to balance the stable of the drone. So it repeats continuously. So next is about the methodology. So methodology, system design, mechanical structure, quadcopter frame X configuration, 4 brushless DC motors with propellers, battery and controller mounted near center of gravity, electronic system ESP32 IMU sensor, electronic speed controllers, lithium and potassium battery receiver, and Bluetooth modules enables remote control inputs. Advantages: low cost, useless, affordable, easy available components, making it budget friendly for students and hobbyists. Customizable and modular, hardware and software can be modified easily to add new sensors, features, and flight modes. Easy to program, Arduino IDE is beginner friendly and supports a large library base for sensors and motor control. Educational value, helps learners understand embedded systems, aerodynamics, control theory, and robotics. Open source support, large online community documentation, open source flight controller, and algorithms are available.
I am Anusha. My topic is disadvantage. Limited processing power. Arduino is slower than professional drone controllers, so adv- advanced features are limited. Manual PID turning needed. Stability depends on PID turning, which is difficult and time consuming for beginners. No built-in safety features features like auto over GPS, return to home, and obstacle advanced are not available by default. Less flight stability, wind, vibration, and sensors noise can affect smooth flying. Next, applications. Aerial photography and videography used to take photos and videos from the air. Surveillance and monitoring help monitor frame construction sites and restricted areas. Search and rescue useful is dangerous or hard to reach locations. Environmental monitoring can measure temperature, humidity, air quantity, and population.
Next, coming to the conclusion, the Arduino-based drone project demonstrates the practical integration of electronics, sensor, and control algorithms to achieve stable flight. By using these open sources hardware and software, the drone provides a cost-effective and customizable platform for learning and experimentation. Through this project, we can gain hands-on experience in embedded programming, PID control, which is based on algorithm, and the sensor calibration and the mechanical assembly. Then coming to the prototype, here it is prototype. This was our project on Arduino drone. Then thank you, sir.